Welcome to qnawire.
Hi, here in this given problem, this is the large wheel over which a rope has been wound like this. A block has been suspended at the end of this rope. Here diameter of the large wheel that is given as 0.800 meter. So its radius will be r is equal to half of diameter, means 0.400 meter. Mass of the hanging block that is given as 10.0 kilogram. So if this is the mass m, its weight mg will be acting vertically downward. Vertical height means the distance moved by the block that is given as h is equal to 2.40 meter in a time duration of 4.00 second. Now, in the first part of this problem, we have to find the final speed, linear velocity achieved by the block and angular velocity achieved by the large wheel after 4 seconds, for which as the block starts moving from rest, so its initial velocity vi, that is taken as 0, and then using second equation of motion in order to find its acceleration, h is equal to vit plus half a t square. For h, this is 2.40 meter. For vit, that will become 0 as initial speed is 0 plus half a, acceleration which we have to find, into square of time, which is 4. So here it will come out to be equal to square of 4, which is 16. 16 by 2 will be 8. So acceleration a is equal to 2.40 divided by 8, means it comes out to be equal to 0.300 meter per second square. So now using first equation of motion, in order to find final velocity of the block after 4 seconds, Vf is equal to Vi plus A into T, means this is 0 plus 0.300 meter per second square into time, which is 4 seconds. So here this final velocity, linear velocity of the block comes out to be equal to 1.20 meter per second. One of the answer for the first part of this problem. Then in the same first part of the problem, we have to find angular speed also. Angular speed of the wheel That will be given by omega is equal to final linear speed Vf divided by radius r. So this is 1.20 meter per second divided by 0.40 meter as radius. So here this omega comes out to be equal to 3.0 radian per second. Second answer for the first part of this problem. Now in the second part of the problem we have to find, using conservation of energy, we will find kinetic energy of the wheel. Using conservation of mechanical energy according to which initial gravitational potential energy of the block when it starts coming down, finally it will be equal to the kinetic energy of the block plus rotational kinetic energy of the disc of the wheel. Means this is mgh is equal to half mv square plus rotational kinetic energy of the wheel, let it be E only. So this E will be given by mgh minus half mv square. Means this is for mass, here it is 10 kilogram, mass of the block is given as 10 kilogram into 9.8 into height through which it drops down, that is 2.40, minus half into mass again which is 10 into square of final linear velocity which is 1.2 meter per second. So finally here it comes out to be equal to 228 joules rotational kinetic energy of the wheel after 4 seconds. Finally, in the third part of the problem we have to find moment of inertia of the wheel, for which we use an expression for the rotational kinetic energy that is given as half I into omega square. Means this is 228 is equal to half I rotational inertia which we have to find into square of omega which was 3 radian per second. So this I here will be given by 2 times of 228 divided by 9, means rotational inertia or moment of inertia of the wheel here, that is equal to 50.7 kilogram into meter square. Answer for the third and the last part of this problem here. Thank you.